So let's look at some examples of how your graph would look, okay, for your inconsistent system. You've got this system of equations written on your notes, and the instructions say you're going to graph the system. So when we look at our system, the second equation is ready to go. You've got your y-intercept, your slope is -1. You can graph that in like 3 seconds. Your first equation is not ready to go. So let's take a quick second and solve for y, which really all you have to do is move the x over, okay? You still need to remember, folks, that when you move the x over, let me get a different color here, you switch the sign. So this first equation becomes y equals -x minus 2. Now let's notice something here. Your slope is -1. Your slope is also -1. Same slope. So if you recognize that, you can stop there and say, I have the same slope. I was just told that when you have the same slope, it's an inconsistent system. You could go straight to saying that it's no solution because your slopes are the same. But if you don't recognize it, you're going to go ahead and graph it, and you'll realize it once the lines are parallel. So you've got your graph there, you got your coordinate plane. Go ahead and graph these two lines, and you will see that you will get a pair of parallel lines. For my first equation, the y-intercept is -2. I go down 1, and to the right 1, there's my first line. Okay, a little off, but there it is. Okay, second equation, my y-intercept is 5. My slope is still -1, so I'm going down 1 to the right 1. When I connect those dots, again, another straight line. They're parallel, they'll never intersect, so you know what you say. You simply write no solution, okay? This is true because your lines are parallel and your slopes are the same. So that's how you'll know that you have an inconsistent system when you're graphing, okay? Now, let's look at letter B. You've got a system here, and they want you to solve it. I'm going to use elimination because that's what's new. That's what we've been working on lately. When you look at this system, you know that you get to choose which variable you want to eliminate. I'm going to eliminate the y. I have a positive 6y, and I have a negative y. I got my plus and minus. All that's missing is the 6 here. So I'm going to multiply this entire second equation by 6 all the way across, okay? So I rewrite the first equation because I haven't touched that. And then I get my second equation with the 6. So that's a positive 18x, a negative 6y, and a negative 12. All right, so now we've got our new system. Draw your line. Now look what happens. My 18x's cancel out. Negative and a positive. My 6y's cancel out. Both variables are gone. I'm left with 0 on the left-hand side. 0 equal to 12. That's not true. It never has been. It never will be. This is how you will recognize your inconsistent system when you are using elimination. The same thing would happen with substitution. So when all your variables go away, they all cancel out, you have a no solution. Easy, just got to recognize it. Next video, we'll talk about the other special case